Hello and welcome to the series of lecture on number system conversion. This is the first part of the video lecture series. This part is purely a basic part. It has no technicality in it. For the sake of completion, I have included this part in the number system conversion series. Well, so what you have read so far? We know that a number system is of two types. One is called positional number system and another is called non-positional number system. So as we have already known, the positional number system is of four types: decimal, binary, octal and hexadecimal. These are the four types of number system comes under positional number system. You might be remember that a decimal number system is built from the digits like 0, 1, 2 up to 9, and a binary number system is built from 0 and 1. Similarly, octal number is built with the help of 0, 1, 2 up to 7, and an hexadecimal number system is built from 0, 1, 2 up to 9. Then A, B, C, D, E and F. This A stands for 10, this is 11, this is 12, this is 13, this is 14 and this is 15. So these are the digits we are using to create a hexadecimal number system. That's all. So this part we have discussed already. Fine. Besides that, we know there are two types of numbers came up for us from our school life. We have seen that. So what's that number? One is called integer numbers and another one is called real numbers or called fractional numbers. So what does mean by integer number? These numbers have no decimal points, but the real number have a decimal point in between the digits of a number. For an example, 564, 789, 34, 6864 all are called integer numbers. Why? Because they have no decimal point in between the digit of this number. But if you check the examples of real numbers, it will be 4.67, 8.95, 456.876. So these are called real numbers because the digits, in between the digits there is a decimal point. So these are called the fractional numbers, or we can say it is a real number. Now the thing is, these integer number and real number may be associated with our positional number systems. Like in a decimal number system can be integer or real. Similarly, binary number system can be integer or real, and also octal and hexadecimal also can be integer or real numbers. So we know that a decimal number is constructed by the help of 0 to 9. So let us take some examples. Like for integer number, 59 base 10 is a integer decimal number. Similarly, 972 is a integer decimal number, and 39.46 is a real decimal number because there is a decimal point in it. 99.96 base 10 is a real decimal number. So similarly, you can check the examples of binary because we know that binary numbers are constructed from 1 and 0. So the integers are 101 base 2, so it is called integer binary number. Similarly, 11001 is an integer binary number. And if you use decimal places in between these numbers, then these are called real binary numbers. Similarly, you can read it for integer and real numbers for octal and hexadecimal numbers. For an example, 5FD base 16, the 16 due to 16 this is extra hexadecimal, there is no decimal places, so it is called integer hexadecimal number. If you check this one, 57.26, so there is a decimal place, the base is given, so this is a real octal number. That's all. So there is a quiz time. Let us check this out. 45.8. So what is that? This is called the octal integer number or integer octal integer number because the base is 8 and it is an integer number. There is no decimal places. Similarly, this is hexadecimal integer number. This is a decimal real decimal number or decimal real number. Real decimal number or decimal real number, you can say. Here it is a hexadecimal number, but it is real hexadecimal number. So real hexadecimal number. This is a real binary number. Real binary because this is decimal point is there. But if you see this one 45, no base is given, so we know that this decimal number can be constructed from 0 to 9. Octal number can be constructed from 0 to 7, and hexadecimal can also constructed from 0 to f. So 45 comes under every category. Like 45 here is 4 5, here is also 4 5, here is 4 5. So we cannot say which base it belongs to, but it is surely it is an integer number, but we don't know which type of number is this, but it is an integer number because there is no decimal places. But in this case 84 it cannot be octal because 8 is not there. It cannot be octal, but it can be a decimal number or it can be hexadecimal number. So but it is integer. Similarly, this is a real number, but we cannot identify the base. But this case a is a hexadecimal number, so it's the hexadecimal real number. And this is also cannot be identified because 101 we cannot directly say that this is binary number because 101 10 all these numbers are also present in decimal, binary, octal and hexadecimal. So this is a real number, but we cannot identify its base. So that's all for this video. And check out the next video for actual conversion. This is the basic part. So from the next video onwards we will discuss about the conversion part. Thank you. See you in the next video.